So welcome everybody to the latest video on 162 Maths, and in this video we'll be going over a GCSE practice paper on the higher tier, set 3, paper 3, which is a calculator paper. Now before we get started working through this paper, a little reminder that a link to the paper is available for you to download and have an attempt at in the description below, and I'll also include a question breakdown so you can see which question refers to which topic should you find any of the questions a little bit challenging or a little bit difficult or not sure how to get started. I'll also include the 162 Maths contents page, which gives you a lot easier access to access lessons which go over the topics in greater detail, as well as topic tests, audits and other exam paper walkthroughs. So let's get started on question 1. So question 1 reads, rearrange A equals B over C to make C the subject. So for this here, if we first of all take C over to the side, so what we end up with is CA equals B. And again, we want to make C the subject, so we want to get rid of the A. A is being multiplied by C, so to get rid of the A, we need to divide by A. So what I'm looking for is B divided by A, which is our third option. Moving on to question 2, it says circle the smallest number from the list below. So what you want to do here is convert each of these. Now, if you just type into your calculator, it may just give you the answer in standard form. You could press the SD in which it will give you as a fraction. But basically what you should end up with if you convert each of the four options is 0.5, 0.01, 0.04 and 0.1. And out of those, which one is the smallest? It's going to be 10 to the power of minus 3. For question 3, it says circle the identity. So again, with the identity, you're looking for a symbol that looks like this, in which it's going to be our fourth option. Moving on to question 4, it says one of these sketches is of y equals x cubed plus 2. Which one is it? Well, because we're looking for a positive x cubed, we're looking for a shape that looks like this. And as it's plus 2, we're looking for a y-intercept of 2. So the only ones it could be is going to be D. So it's either going to be A or D. A has a y-intercept that's less than 0. B and C are both quadratic graphs, so the actual answer is going to be D. Moving on to question 5, it says that a spinner lands on red, blue or green. The relative frequencies are after 400 spins as shown. How many more times did it land on red than green? So for this, for relative frequency, the formula is the probability multiplied by the number of trials. So for red, we're going to do 0.35 multiplied by 400. And if I type that into my calculator, I get an answer of 140. And if I do the same for green, I'm going to do 0.15 multiplied by 400, and I get an answer of 60. So all that's left for me to then do is work out the difference between those two numbers by subtracting, and I get an answer of 80. Moving on to question 6, so our loci question. So let me just leave it as there. It says use a ruler and a compass for this question. This ship is closer to port X than port Y and is less than 11 kilometers from Y. The map below shows the positions of X and Y. On the map, show the region where the ship could be, and we will label this R. Now for this, what we need to do is, for the first part, what we need to do is we need to do a perpendicular bisector between X and Y, and we want the region that is that's closer to X. For the second part, so for this here, so less than 11 kilometers, using a scale of 1 centimeter equals 2 kilometers. For this, what we want to do is draw a circle with a radius of 5.5 centimeters around Y. Now the region R is on the side of the line closer to X and is inside the circle of Y. And let's have a go what that should look like and how to do that. So to work this particular question out, as we mentioned, to get the closer to port X than port Y, what we need to do here is we need to do a perpendicular bisector between X and Y. Now to do that, what you need to do is first of all grab your compass and your pencil. Now again, we make sure that your compass is quite stiff so that we don't have much movement when we're doing our arc, and when you close your compass that the tip of your pencil is as close as you can to the pin of the compass. Now here, putting your pin on X, what you want to do is make sure that the pencil is more than halfway. It doesn't really matter how far you do it. And then what you want to do is then draw an arc between X and Y, and hopefully you can see that arc on the screen. Now again, without adjusting the compass, put your pin on Y and draw another arc in between, and what you should find is that the two arcs do cross. Now if I just highlight that there, so there's one intersection point and there is another intersection point, and then with a ruler, what I then want to do is join those intersection points up, and what we've got here is that this side is closer to Y and this side here is closer to X, and this is the side that I'm wanting. So the next thing that's left for me to then do is to then draw the boundary, which is 11 kilometers away from Y. So with the ruler and the compass, what you want to do is measure 5.5 as best as you can, which can be a little bit fiddly depending on your compass. And then what you then want to do is put the pin on Y and draw a circle. Now this can get a little bit confusing because I've now got two arcs from Y. You just need to make sure which one you're picking. And if I do it in a different colour, so if I just highlight that in red, and this is the arc that we're looking for. Like so. Now in this, under no circumstances do you want to rub out any of your construction lines, so please make sure you leave it where you've got all your construction lines done, but you just need to keep a record of which one's which. Now as mentioned at the start of the question, we're looking for the side. It's got to be on this side and it's got to be inside the circle. So the only area that satisfies that region where it's on the left hand side and inside the circle is this region here. And again, all I then want to do is just label that as R. Now moving on to question 7, it says that a solid shape is made with a cube and a cylinder. The cube has edges of length of 3 centimeters and the cylinder has a diameter of 1 centimeter and a height of 3 centimeters. The cylinder sits symmetrically on the center on top of the cube as shown, and the question is asking us to draw the front elevation on the centimeter grid below. Now the front elevation is going to be this here. So what we're needing to do is we're needing to draw this plus the cylinder, and what that then would look like is something that looks like this. For 7b, it then says the cylinder now sits symmetrically on top of the cube as shown, and it says draw the front elevation and the side elevation on the centimeter grid below. So again, if we take the front elevation as being this, so that's going to be this face here and that there, then what that's going to look like is going to look like our square with a vertical rectangle on top. Now for the side elevation, let's just go for that and be in orange. So that's going to be here. That's going to be the square with a circle. And so what that's therefore going to look like is looking like this. And again, you need to make sure that they are neat. You are using a pencil, you are sticking to the lines, and you are using a compass and a ruler. Moving on to question 8, it says that a distance time graph shows the journey of a toy train. And it says here are some descriptions of the first two parts of the journey. Now the first two parts are this part here and this part here. Oh, don't know what's happened there. So we're just looking for this line here and that there. Now it says circle the correct description, and the one you want to circle is going to be B, in the fact that it moves at a constant speed, which is represented by a straight diagonal line, and then it's stationary, which is a straight horizontal line. For 8b, it then says work out the average speed for the last 4 seconds of the journey. Now the average speed is the distance divided by time. So if I go back to the graph, the last 4 seconds is this region here, which again, excuse the closeness to the line. So looking at the distance is 10 take away 4, which is 6, and the time is 4 seconds. So for B, the speed is going to be equal to 6 over 4, which is 1.5 meters per second. So if I go back to the question, I just need to write 1.5. Can you write it as a fraction? Yes, you can. So you could write it as 3 over 2 or write it as 6 over 4. Moving on to question 9, let's just zoom in so we can see it all on the screen. It says, here is a frequency table for the times taken to solve a puzzle. Circle the class interval that contains the median. Well, the median is going to be at the total number of trials, or the total frequency, which is 100 divided by 2. So it's the 50th number that I'm looking for. So what I'm looking for in this community of data is where would the 50th number be? So again, if I did a community frequency column, that'd be 38, and then that would be 54. So as you can see, the 50th number is going to be in the second group. So what I need to do is circle the second option. Moving on to question 10, it says, here is a rectangle and a T-shape made from 2 rectangles. And the question is asking me to show that the rectangle and the T-shape have the same area. So if we keep on the screen so you can see it, if I just label this shape A and this shape B, that the area of A is going to be the height times the width, so that's going to be 7 lots of x plus 1, and expanding the brackets is 7x plus 7 centimeters square. So that there is the area of A. Now for the area of B, this is a compound shape, so if I split that up in this way, that this part here is going to be 2 lots of 2x plus 5, and this bottom section by the height and the width is going to be 3 lots of x minus 1. So the total area of B is going to be those two expressions added together. So I've got 2x plus 5 plus 3 lots of x minus 1, and expanding the brackets I end up with 4x plus 10 plus 3x minus 3. Simplifying that, collecting the like terms, I'm going to get 7x plus 7, and as you can see, these two expressions are the same. So if I just highlight the fact that those two things here are the same, I've then answered the question. Moving on to question 11, it says the area of shape A is 36 centimeters square. Shape B is similar to shape A with sides of 4 centimeters times bigger. Circle the calculation to work out the area of shape B. So here what I need to know is that the length scale factor is 4. So that means that the area scale factor is going to be 4 squared or 16. So to work out the area of B, it's going to be 36 times the area scale factor, which is 16, or 36 times 4 squared, which is our fourth option. For question 12, it says I'm thinking of two numbers. If I multiply the first number by 4 and the second number by and add the second number, the answer is 32. If I multiply the first number by 2 and add the second number, the answer is 23. Work out the two numbers. Well, if the two numbers are, if I label the first number as A and the second number as B, then looking at this first expression, what I end up with is 4A plus B equals 32. Now if I then convert the second statement using algebra, that gives me 2A plus B, which equals 23. And as you can see, it's now turned into a simultaneous equation. So when I've got simultaneous equations, I need to check the quantity of each of the two variables or the two letters and see if they're the same. So as you can see, I've got B's the same. So then I look at the sign of the B's where they're both positive. So I'm going to subtract the two equations or expressions, I say, formulas. So looking at this, we've got 4A take away 2A, which is 2A, B take away B, which is nothing, and 32 take away 23, which leaves me with an answer of 9. So then 2A equals 9, so therefore A must equal 4.5. So then all that's left for me to then do is now work out what B is. So using one of the statements, and I'm going to go for 2A plus B equals 23. I know that A equals 4.5, so 2A is going to equal 9. So 9 plus B equals 23. take the 9 over and end up with b equals 14. So here I can say that a is 4.5 on my first number, and the second number, which is b, is 14. Moving on to question 13, it says that here is a formula: s equals 5t squared. S is the distance in meters a ball falls when dropped, and t is the time taken in seconds. For 13a, it says a ball is dropped from 2 meters above the ground. Work out the time taken for the ball to hit the ground. So for this, we can say that s is going to equal 2. So then substituting that into the formula, what I end up with is 2 equals 5t squared. So I want to make t the subject, so I take the 5 over. So 2 over 5 equals t squared. So therefore t equals the square root of 2/5, which if I type into my calculator, I'm going to get an answer of, and let's just quickly do that now. I get an answer of 0.632455532. And again, we're not looking for a plus and minus because time can't be negative. So you just want to round this number up or write it in all its entirety. So I'm going to round it up and I'm going to say it's 0.63, and that's to 2 decimal places. Now remember, when you are rounding, make sure you always state what you're rounding it to, and just double check the units, which is already given to me in this question. Moving on to 13b, it says which of these statements is true for the ball. So if it falls 2 meters in exactly double the time it falls for the first meter. If it falls 2 meters in less than double the time it falls in the first meter, and in the last option it falls 2 meters in more than double the time it takes for the first meter, you must show you're working out for this answer. Well, if I just draw a particular 2 meter drop, so this is the start, this is the finish, and this is the ball. Now here, if the ball is dropping, now this section here is the first meter, and this region here is the second meter. Now what the question is asking, is it a constant speed? So is the speed that it's going to be falling in the first bit going to be the same as the speed falling in the second one, or it's in its entirety? So is the total speed going to be faster or smaller than the yellow or the pink? So for this, it's actually going to be less than double, and the reason for that is that the ball will be accelerating. It's really important that you do include that word of acceleration or accelerating. So therefore, that the ball will take, so in the second meter, it will be quicker. Because you think that when the ball starts from 0, as it goes on, it's going to get quicker and quicker and quicker, because obviously the gravity then starts taking over. So again, you could measure the average speed, but in that first meter, the second meter will be faster than that first meter. Moving on to question 14, it says these two shapes are similar. Work out the value of x. Now for this, what we need to do is first of all work out the length scale factor, because x is a length. So the length scale factor, and what we do is we find the two corresponding sides, and the scale factor is the side on the big shape or the final shape, which is 12, not 8. So let me just get rid of that, and divide that by the corresponding side on the original shape. So here we've got a scale factor of 3/2. Now to work out x, we're going from small to big. So I'm going to multiply the side that corresponds to x, multiply that by the scale factor, which is 3/2, and that's going to give me an answer of 9 centimeters. Again, don't forget to write the units. For question 15, it says y equals 10 over x squared. What happens to the value of y when the value of x doubles? Now for these types of questions, I always recommend substituting numbers in. So if I wrote x equals 1, then y is going to equal 10 over x squared. So that's going to be 10 over 1, which is 10. Then if x doubles, so that's going to be 2, I'm going to end up with y equals 10 over 2 squared, which is 10 over 4, which is 2.5. Now what you then want to do is compare the two answers. So what's happened to 10 to get to 2.5? Well, the correct answer you want to be able to circle is going to be that it's been divided by 4. Moving on to question 16, it says that a tank is filled with water at a constant rate. The tank is a cuboid of height of 80 centimeters. The tank is full after 15 minutes. CETA draws the graph to show the depth of the water during the 15 minutes. And the question is asking us to make 2 criticisms of CETA's graph. Well, the 2 things you need to be able to spot is the fact that, 1, as it's a constant speed, so constant speed equals, that should be a straight line, and the reason for that is because the shape is a prism. So it's a constant speed and it's a prism, so it's got a constant depth. So the line should be straight. So that's the first thing that should happen. And then the second criticism, which I didn't spot initially, but is the fact that depth is missing some units. So you could say here for the second criticism that the units is missing for the depth or the vertical axes. So something along those lines would be absolutely fine for those 2 criticisms. Then moving on to question 17, it says some girls and boys take an examination. Here is some information about the marks for the girls, and then we've got, now the question is asking us to draw a box plot. Now to draw a box plot we need 5 bits of information. We need the lowest point, the highest point, the lower quartile, the upper quartile and the median. So for this there's no further calculations I need, I just need to plot these values. So 16 is, now each little box represents 2, so that's going to be there. For highest one is 78, so that's going to be there. For the lower quartile, that's at 24, so that's going to be there. The upper quartile at 66, so that's going to be there. And the median is at 48, which is going to be there. So all that's left for me to then do is to make it look like a box plot. Now again, I'm not using a ruler or doing this very neatly. You need to make sure that you are using a ruler and it is drawn neatly, but it should look something that looks like that. Then moving on to question 17b, it says here is some information about the marks for the boys, that the median is 45 and the interquartile range is 39. Whose marks are more consistent? Now more consistent basically means a smaller IQR. Now for the boys IQR, it tells us in this information that it's 39. Now for the girls, what I need to do is I need to do the upper quartile minus the lower quartile, which is 66 minus 24, which gives me an answer of 42. So as you can see that the boys have got a smaller IQR, so the box I need to tick then is the boys. And again, you could say that the boys have a smaller IQR, but it's really important that you do show your calculations for this, just to add a bit of evidence. Moving on to question 18, so let's just zoom in as it's a rather smallish question. So it says A, B and C are positive integers. A to B is in the ratio of 5 to 6 and B to C is in the ratio of 8 to 11. Work out the smallest possible value of A plus B plus C. So when we're combining ratios together, what we need to then do is, first of all, let's write each of these. Now you can see that B is our shared letter. So if I write A to B, that's 5 to 6, and B is 8 to 11. Now what I'm wanting to do is to write B so that as a common multiple of 6 and 8. Now the smallest common multiple of 6 and 8 is going to be 24. Now to get from 6 to 24, I need to multiply by 4. So 5 times 4 is going to be 20. Then to get from 8 to 24, I need to times by 3. So 11 times 3 is 33. So these are the smallest possible values of A, B and C. So the smallest possible value of A plus B plus C is going to be 20 plus 24 plus 33, which on the calculator, if I add that up, is going to give me an answer of 77. Moving on to question 19, it says Tom picks a 3-digit even number. The first digit is greater than 6. The second digit is less than 7. How many different numbers could he pick? Well, for the first digit, the options are either going to be 7, 8 or 9. For the second digit, it's going to be less than 7, so it could be 0, 1, 2, 3, 4, 5, 6. And for the third digit, as it's an even number, that it needs to either end in 0, 2, 4, 6 and 8. So then to work out the total number of combos, well, the total number of options here is 3, total number of options here is 7, total number of options is 5, so that's going to be 3 times 7 times 5. If I enter that all on the calculator, I get an answer of 105. Moving on to question 20, it says here is a diagram of a pack of cereal. Eve has a daily allowance of 260 grams of carbohydrates. She says that one serving gives more than 9% of my daily allowance. Is she correct? So for this, the first thing we need to do is work out what 9% of 260 grams is going to be. So to do this, if I use my decimal multipliers, that's going to be 0.09 multiplied by 260, and that comes up to 23.4 grams. So this statement, this is the actual daily allowance. So now what's left for me to then do is work out what one serving is, how many carbohydrates there is in one serving. So to work out the amount of carbs in one serving. So for this, let's first of all work out the total grammage for one serving. So one serving equals 360 divided by 12, which is 30 grams. Now looking at this here, what I want to do is work out what the proportion of carbohydrates is in per 100 grams. So that's going to be 79 over 100, and that tells me how many carbohydrates there is in 100 grams. So if I divide by 100, I get how many carbohydrates there is in 1 gram, and I want to know how many carbohydrates there are in 30 grams. So if I do this calculation here, I end up with an answer of 23.7 grams. So the two amounts that I want to compare are 23.7 and 23.4. So here, is she correct? That's by saying that there are more than 9%. That's going to be true. So the answer then is she correct? Yes, as 23.7 is greater than 23.4. So something along those lines would be fine. Now there are other ways of explaining that she is correct. And again, if you've done a different method and you still prove it's true, then please do check out the Markscheme to see if your answer would be allowed for those 4 marks. Now moving on to question 21, it says prove that 5n minus 2n plus 3 multiplied by n plus 1 is always negative. So for this, what we need to do is first of all expand the brackets, but be careful with the minus. So if I just write 5n minus, I'm going to put the square brackets in. Now if I expand this out, what I'm going to end up with is 2n squared plus 5n plus 3. Now if I remove those square brackets, I end up with 5n minus 2n squared minus 5n minus 3. Now from this, if I simplify this, the 5n's cancel. So all I'm left with is minus 2n squared minus 3. Now for this, what we now need to do is there's 2 ways in which you can do this. If I factorize, take a minus out, I've got minus 2n squared plus 3. So therefore, it's always negative, as 2n squared plus 3 for all values of n will be greater than 0. So if the bracket is always going to be greater or equal to 0, then sticking a minus there means that the answer will always be negative. Now another alternative you could say is something along the lines of that n squared is always going to be greater or equal than 0 for all values of n. So therefore, minus 2n squared is always going to be less or equal to 0. So then if that is true, then subtracting 3 from this will always be negative. Now if the biggest value that ends to minus 2n squared can be 0, 0 take away 3, it's going to give you a negative answer. So any of those two explanations will be absolutely fine, but it is important that you do write a statement just to confirm it and don't just leave your answer as minus 2n squared minus 3. You'll need to explain a little bit further as to why the answer will always be negative. Moving on to question 22a, it says write x squared plus 6x plus 10 in the form of x plus a squared plus b, which is basically completing the square. So for this, what we need to do is first of all set up our bracket. So the number that goes inside the bracket is always the half the coefficient of x, which is 3. So 6 divided by 2 is 3. I stick the constant and I always subtract whatever number I've written inside the bracket or the digit squared. So that's going to be x plus 3 squared plus 10 minus 9, which leaves me with x plus 3 squared plus 1. And that there is my final answer. It then says, hence write down the coordinates of the turning point of the curve. Well, the turning point, when you have it as x plus a squared plus b, is always going to be minus a plus b. So it's always the value of x that makes the bracket equal to 0. So that's going to be minus 3. And the y of the turning point is always the constant at the end, which is positive 1. Moving on to question 23, it says use the iteration of xn plus 1 equals 4 over 2 over x squared n. Work out an approximate solution to this, starting with the value of x1. Now if I load the calculator up, now the first thing you need to do with these types of questions is always make sure that you are writing a few of the iterations before you go a little bit crazy with the equals button. So it says that my first value is 1. So if I get my calculator, which is what you're going to be expected to use, and it should load up anytime soon. There we go. So you want to enter the first number, press equals, and then what you then want to do is then enter the expression exactly what you've got, but replacing xn with ands. So I set up my fraction, I've got 2 over ands squared. Now if I press equals, that gives me 2, so my second value is 2. Get the calculator back up, press equals again, that's my second value, so it's 3.5. Then press x4, which is 3.83, so 3.836, blah blah blah. Now if you want to write down the next few, that's entirely up to you. So the next one will be 3.8641, and again just write a few dots. But the solution is basically when you keep pressing equals is when it stops changing. So here the solution is going to be 3.866198263. Now it says to give your answer 2 decimal places, so x is going to equal 3.87, and that's to 2 decimal places. And again, really important that you do show the first values. Don't just go straight into your calculator to write down the answer, because the question is worth 3 marks. Now moving on to question 27, it says the diagram shows a vertical tower CD of height h. ABC is horizontal and AB is equal to 40 meters. Work out the height of h of the tower. Now to work out h, what I need to do is I can see a right angle triangle. I'm going to use trig because I've got lengths and angles and triangles. Now in order for me to work out h, I need to know what either BC is or BD is. Now because you can see 2 triangles, the shared side is BD. So what I need to do is I need to work out what this length here is going to be. Now if I take out the triangle ABD and just draw that out, so A, B and D. Now the measurements I know that this angle here is 26, this length here is 40, and this length BD is what I'm wanting to work out, which I'm just going to call X. Now in order for me to work out what X is, I either need to know the length of AD or I need to know what one of the angles are. Now, as I know that I'm going to be using the cosine or the sine rule, I need to work out opposite sides of opposite angles. Now, they've given me 40, so the angle I need to work out is going to be this angle here. Now, unfortunately, I can't just use the protractor because it's not drawn accurately. So what I need to do is go about working out what angle D is going to be. Now, I can work out what this angle here is going to be because it's on a straight line. So that's going to be 180 minus 32, which is 148. Now, I know that angles on a triangle add up to 180. So to work out this angle here, I'm going to do 180 minus 26 minus 148, which comes up to an answer of 6. So that angle there is 6. So now from this triangle, I can now use the sine rule to work out what x is going to be. So using the opposite angle. So I know that x over sine 26 is equal to 40 over sine 6. So now using this, if I just take this, oh, don't know what I've done there. So if I just take this over, so I've got a little bit of space, let's do that over here. So I wind up doing a bit of cross multiplying. I get x sine 6 equals 40 sine 26. So therefore x is going to be 40 sine 26 over sine 6. So x is going to give me a value of 167.7518766. And again, I've just copied that answer off the calculator. Now if I just move down so I've got a bit of space, now if I draw the triangle BCD again, BCD, I know this angle here is 32. I know that this length here is 167.7518766. And this is the height h, which is what I'm working for. Now, labelling it h is a little bit confusing because when I'm using trig, h usually represents the hypotenuse. So what I need to do is just make sure that I'm using the right trig ratio, and it's going to be using SOHCAHTOA trig. So which SOHCAHTOA uses O and h, it's going to be sine. So sine theta equals O over h. So substituting the values in, I've got sine 32 equals h over 167.718766. Now again, I'm going to use the exact answer. If you want to use a rounded answer, that's entirely up to you, but don't round up too much. That's the only thing I would suggest. So then h equals 167.718 blah 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 multiplied by sine 32, and if I type that into my calculator, I get an answer of 88.89495102. So h is going to equal 88.9 meters, and that's to 1 decimal place. So an answer roughly around 88.9 is entirely up to you. Now if you have rounded the answer up, again, always make sure you've stated what you've rounded your answer to, but there's no specified way that they want there to write the answer, so it's entirely up to you how you want to do it as long as it is correct. Moving on to question 25, it says that an empty container has a capacity of 80,000 litres to one significant figure. Mel pours 7,400 litres of water to two significant figures. She says, I filled more than 10% of the container. Is she correct? Now this is an upper and lower bounds problem solving question. So the first thing we need to do is find the upper and lower bounds of the rounding. Now the container to one significant figure is basically to the nearest. Now the first figure in 80,000 is to the nearest 10,000. So then to work out the upper and lower bound of the container, it's going to be the measured amount plus and minus half of what you've been rounding it to. So half of 10,000 is 5,000. So to find the upper and lower bound, I need to add and subtract 5,000. So that's going to be 75000 and 85000. Now the water poured is the next one. Now this is done to the second sig fig, which is to the nearest 100. So again, if I do the quantity measured, which is 7,400 plus minus, and I halve what the rounding was, so that's going to be plus minus 50. So the upper lower bound is going to be 7350 and 7450. Now, in order to get the worst case scenario, because we want to make sure we've got the worst case, what we're wanting is we're wanting the fastest water and we're wanting the so we want the worst rate that we could have to make sure it's the case. So the fastest water over the smallest container. So for this, it's going to be 7450 over 75,000. And if I type that into my calculator, I get an answer of 0.09913. And again, convert that into a percentage. If I times that by 100, we can see that it's going to be 9.913%, which is less than 10%. So is she correct? The answer is going to be no. Moving on to question 26, it says that a bag contains 12 discs, 7 are red, 3 are blue, 2 are yellow. 2 discs are taken from a bag at random without replacement. Work out the probability that 2 discs are the same colour. So for this, what we need to do is draw a probability tree. Now, it's not the only way, but it's certainly the one that's probably recommended with the space given in the question. Now, in terms of, because we're picking 2 counters, we need to know we've got 2 steps in there. Again, what I'm going to try and do is try and keep this consistent, but I think I'm going to run out of space. Yep. So completing the probabilities, I've got 7 over 12, 3 over 12, and 2 over 12. So if I pick a red one first, that means I'm going to have 1 less red counter, and I'm going to have a total of 11. I've not picked any blue ones yet. If I've picked a red one first, that's going to be 3 over 11, and this is going to be 2 over 11. If I've picked a blue one first, it means I'm still going to have 7 red with 11 counters because one's already taken. I'm not replacing it. Blue, I've taken 1, so I'm only going to have 2 left, and I've got all the yellow ones left. If I've taken a yellow one first, I've got all the red ones. That should be over 11, not 12. Let me just correct that. Then blue, I've still got all the blues, so that's 3 over 11, but I've got 1 less yellow. So now for this, the same colour is either going to be red, red, or blue, blue, or yellow, yellow. Now in terms of this, remember, or means plus, so red and red, I multiply the fractions, so that's 7 over 12 multiplied by 6 over 11, plus blue, blue, which is 3 over 12 multiplied by 2 over 11, oh, not 111, plus, and then yellow, yellow, which is 2 over 12 times 1 over 11. So adding all of these up, I end up with 42 over 132 plus 6 over 132 plus 2 over 132, which gives me a total of 50 over 132, which I can simplify as 25 over 66. So any of those 2 answers would be absolutely fine as your final. Now moving on to question 27, it says Sam runs for 10 minutes. The graph shows his pulse in beats per minute, and the question is asking, by drawing a tangent, work out the rate of which his pulse is increasing after 3 minutes. Give units for your answer. Now for this one, there are multiple particular answers, and it all depends on how you are doing this. Now the first thing you need to do is first of all find 3 and draw and mark the point. Now what we're wanting to do is we're wanting to draw a line with a positive gradient at tangent at that point that I've marked there. So what you then want to do is with a ruler is draw a straight line, and imagine that a straight line is balancing at that particular point with that is your intersection. As you can see, my line's not quite touching with the point or even with the line, so you just need to make sure it is accurate. It's an absolute nightmare to do this on the computer, but I'm going to show you how to actually do this. Now what helps with this particular question is the fact that your line should be try and make it as long as possible, just to make your life a little bit easier. Now let me just have a really poor attempt at doing this. And again, it's really difficult because I can't do it on the screen as much as I'd want to, and again I can only do it like so, but you just need to draw a line with positive gradient. I'll say that might be the closest I'm going to get. Now with this, what you then need to do is convert this into a right angle triangle, and what you want to do is you want to work out the gradient of the tangent. Now to work that out, it's basically the distance up divided by the distance across. Now looking at the distance up, one little square equals 1, and going across, one little square equals 0.2 minutes. So counting the squares going up divided by the counting squares going down, but remember you need to make sure you're multiplying the denominator by 2. So if we look at the number of squares up, and I mean the small squares, divided by the number of small squares multiplied by 0.2. Now if you work that division out, you should end up with an answer between 9.4 and 9.8. Now again, if your answer falls outside of that, as long as you've drawn a tangent at 3, it looks like a tangent, so it's only touching the curve at one point, which is at 3, you should be absolutely fine. Now the units you need to then write, because the units going up is the pulse per minute, is beats per minute. Is beats per min. And we're dividing that by time, which is in minutes. So that means that the units are going to be beats per minute squared, because we've got minutes divided by minutes. So here you could say, in terms of units, you could say something along the lines of beats over minutes squared. But you need to make sure that you are either writing it per, or you're writing like this. And again, you're expecting an answer between and inclusive of 9.4 to 9.8. Moving on to question 28a, which I believe is our last question. It says, here is a triangle ABC. Describe fully a transformation of the triangle of which all points on BC are invariant and there are no other invariant points. So basically what invariant means is that it does not move. So here, if BC doesn't move, then what we're looking for is the new transform shape, or the image is going to be this here. So this here is our image. So possible answer you could say is that it's going to be a rotation with the line, sorry, not rotation, it's going to be a reflection. And we just then need to state the equation of the line of reflection, which is at y equals 1. Then moving on to question 28b, it says, here is a shape of an L shape PQRSTU. Describe fully a single transformation of the L shape for which only one vertex is invariant. The line joining P and Q remains vertical and the area of the L shape does not change. Now for this, there are several and quite a lot of different answers. Now for this, possible answer you could write, and I can't go through all of them, otherwise it'll take the video up to about 3 hours. So here you can either, so first, I'll show you, answer 1 is either that it's going to be a rotation of 180 degrees with a center of either P, Q, R, S, T or U. So any of those letters, obviously only pick one. Or the second option you could say is that it's an enlargement of, with a scale factor of -1, and the center of that enlargement is either going to be P, Q, R, S, T or U. So any of those particular answers would be absolutely fine. Again, I would strongly recommend you draw your particular shape on there and then decide and write down which transformation it's going to be. Now again, remembering that invariant basically means that one point does not move and the line joining PQ remains vertical. So this line has to stay vertical. So either it could be there or it could be there, but that PQ does need to be vertical. And again, that's one of the reasons why. And it says that the area of the L shape does not change. Therefore, it can't be an enlargement with a scale factor that's outside of -1 or 1. Otherwise, the shape will get bigger. But enlargement is a possible answer.